Hi, I'm Tom Kenny. I own Scott Simpson Builders with my partner Scott, and we are a construction company that focuses on green building practices. The thing that makes this house different from other houses by being green is we're trying to be as efficient with energy as we possibly can. Well, we like to use renewable energy a bunch of different ways. The first way in this house we like to use renewable energy is we've got solar panels on the roof, and we circulate a fluid through these panels, and as the sun travels over the horizon, it heats up these panels or heats up this fluid. We take this fluid that gets to be about 180 degrees and we circulate it through the floor, and that will heat up the floor and actually heat up the house. We use the same solar panels in conjunction with heating the floors to heat up the domestic hot water, so that we use this energy that we're getting from the panels to heat up the domestic hot water, so that when you turn on the showers you get hot water. So that's one way. Then we're using photovoltaic cells, which are also solar panels on the roof, and as the solar energy comes across the horizon, it hits these cells, and that makes electricity, and we use that electricity to power the lights and the appliances and the garage door and the refrigerators, things like that. We're planning on putting wind turbines on this house. Since this house is right on the lakefront in Lake Michigan. We're going to put wind turbines, and we're going to try to collect the energy from the wind here. Yeah, we figure out how much energy we need a couple different ways. The first thing we need to do is we need to make sure that there's enough energy to heat the house during the winter time and cool the house in the summertime. So we can do a load calculation, and we can figure out how much heat loss we have per room based on how many windows there are, how much insulation there is in the walls and in the roof structure, and we can actually figure out by these calculations, which we use BTUs. So like if like each room loses 300 BTUs an hour, we can figure out how big the furnace needs to be downstairs in order to keep the temperature in the room at 68 degrees when the outdoor temperature may be -10. And we can do those calculations. So we know how much energy we're losing outside the walls and through the windows. The other calculation we do to figure out how much energy we need is we figure out how much electricity our appliances need, the garage door, the lights in the house. And once we add up how many amps all that energy needs and how much of that we're going to use continuously, we can figure out what size the electrical service needs to be, whether it's 200 amps or 300 amps. The other calculation we would make is you want to have domestic hot water. So we figured out how many occupants are in the house. The shower heads may give off like 2.5 gallons of hot water per minute. We figured out how many shower heads will be used in the first hour. And then we can figure out how big of a hot water heater we'll need. So we figure if you've got a big family, you might need 100 gallons of hot water in the morning. If you're a small family, you only need 50. And we can figure out what size hot water tank we need to put in to give you guys so we can deliver that hot water on demand. This is the photovoltaic sensor that tells us how much energy we're making on the panels, the photovoltaic panels up on the roof. Right now it's reading at 586 kilowatts. So this actually tracks how much energy we're gaining from the sun as we use the energy through this house. This is the solar hot water tank. And so what we're doing here is we're pumping this fluid up to the solar panels, and as the sun's shining, it warms up these panels and heats this fluid up and comes down and gives us solar energy. And right now the energy that's coming down off the roof, it's about 4:30 and it's not sunny outside at all, it's 85 degrees, but we're taking that extra energy and we're using that to heat up the hot water that we're using in the floor, and this will heat up the building. Like this concrete floor is being heated by solar energy, as well as the first, second, and third floors. And then when the sun is not shining and we need backup heat, we use this boiler. Now this is a gas-fired boiler, and what it does is it takes the energy from the natural gas, which you're piping in here, comes in. We've got a burner. We heat up this hot water. We heat up this water, make it hot, and we circulate it throughout the house to help heat the house. This solar energy is also used to heat the domestic hot water. So this is the domestic hot water tank, and once we bring this temperature up to about 120 degrees, we're able to deliver to your sinks and faucets and shower hot water for taking showers and washing dishes and things like that. And learn how to do something you were forced to go back and do the math and science to figure it out. I mean, that's just, I wanted to do it, I want to do this, and so I had to, you had to go back and solve the problem. It's like the scientific method, you have a problem, you got to figure out what the hypothesis is, and then you've got to test the hypothesis. I mean, it's just like I needed to go and learn how to do it. I think what happened was we really got interested in trying to minimize the impact to the environment. I mean, my interest, really, my true interest is finding a way to build a house that does not have to rely on the grid. And in this house, we actually are very, very close to being off the grid. We're not going to need electricity during some parts of the day because we're going to make our own energy. And my interest is actually in finding a way to build someone's house, make them comfortable, that does not have to rely on the grid, an electric company, or natural gas. That's what I became interested in doing. Yeah. And in order to do that, you had to go through a lot of math and science to figure that out. And we haven't done it yet. We're still working toward it.